Hey guys, welcome to another video for pre-calculus. In this video we're going into chapter 10 section 1. We're going to be dealing with sequences, series, and sigma notation. Okay, so let's go ahead and get started with the fundamentals of sigma notation. And in this case we're going to be looking at a series of numbers, and the problem asks us to find the next four terms for the sequence. So here are the numbers. And then we're being asked to find the next four numbers to this series. Now, one of the easier ways to look at this, or to find the answer to this, you can just use the basic operations that you know of. You're looking for patterns. So, are you adding the same number each time, to each number? Are you subtracting? Are you dividing by the same number? Are you multiplying by the same number? So when I get from 1 to 8, what's the difference? What am I doing? From 8 to 15, from 15 to 22. And if there's no obvious pattern for multiplication or division, one of the things I would say is that you then look for the difference of these numbers. So what's the difference between 8 and 1? And that is 7. And then I look at the difference between 15 and 8, and that is also 7. And then the difference between 22 and 15, and that's also 7. So in this case, the term appears to be increasing. It appears to be increasing by 7 each number. So now it's asking me to find the next four terms. So that would be 29, 36, 43, and 50. And then likewise, as I continue, if I look at number 3, I have this sequence of numbers. And as I look at this number, again, this is about pattern recognition. And the pattern that I see here from 88 to 27, 27 to 9, and 9 to 3 is a division of 3. So I'm going to check that. So 81 divided by 3 is 27. 27 divided by 3 is 9, and then 9 divided by 3 is 3. So I can pretty much confirm that that's my pattern. So then the next thing I want to do is I want to find my next four terms. And 3 divided by a third, or by 3, is the same as 3 times 1/3, and that is 1 over 9. So that's 1 over 9. Actually, I take that back. That's not 1 over 9. That's 1 over 3. Actually, if I divide 3, let me back up here. If I divide 3 by 3, because each of these is dividing by 3, right? If I divide 3 by 3, then that's 1. And I divide 1 by 3, that's 1/3. And divide 1/3 by 3, that's 1/9. And then 1/27. And that's my final answer there for number 3. So as I look at the next problem that I want to work out, I'm looking at number 12. And what this wants me to do, it wants me to find the fourth term for this formula here. So you have a to the n, and then I'm being given a very specific formula, and then plus 10, and then your n must be greater than or equal to 2. Okay, and so I'm looking for the fourth term, and it also tells me that my a1 term is 5. So now this kind of formula is called a recursive formula. So let me go ahead and write that in there. It's a recursive formula, and what that means is that in order to find my fourth term, I actually can't solve it without knowing what my third term is, and I can't know my third term without knowing what my second term is, and I can't find my second term without knowing what my first term is, and I do know what my first term is, so I can use that. I can use this first term, and I can actually plug it in. Whoops! I can plug it in. I can plug it into the equation here, and that will help me. That will kind of get the first domino going in solving for this problem. So I'm going to find the value of a to the 2 because I know what a to the 1 is. That's 5. And a to the 2, I go to my formula. That's going to be -3. -3. And again here, you see an. My an is 2 minus 1. Okay, and then plus 10. So if I rewrite this, if I look at this, if I compare this part of the formula to what I have here, right, and that's what I'm going to be doing. So you'll notice that it's an, and my a to the n is 2 So it's going to be 2 minus 1. So it's going to be 2 minus 1. 2 minus 1. So that's going to be negative 3. Negative 3a to the 1, right? And then plus 10. So what's a to the 1? A to the 1 is equal to 5. So I plug that in. Negative 3 times 5 plus 10. That gives me a negative 15 plus 10 equaling negative 5, right? Okay, so now I know what the value of my a sub 2 is. So now I use that value to help me solve for the third term. So a3 will equal negative 3, a3 minus 1 plus 10. So that's going to be negative 3, a2 plus 10. And what is the value of a2? It is right here. It's negative 5. So then that will be negative 3 times negative 5 plus 10. Okay, and then that's going to be 15 plus 10, and that will equal 25. So now I know the value. Now I know the value of a third. Right? So I'm going to erase this part here. Don't need this anymore. Okay, so I know the value of a3, and again I'm looking for the fourth term, so this is my last one. So a to the 4 equals negative 3 times a, make sure what happened there, an minus 1 plus 10. So that's negative 3, 4 minus 1 plus 10. That's negative 3 to the third term, a to the third plus 10. So that is, and I know the value of a to the third, a sub 3, that's 25. So that's times 25 plus 10 equals negative 75 plus 10 equals negative 65. And that is what my answer is. So that's the value of my fourth term, is negative 65. So I'm looking at 14 right now. And 14 asks us to find the fourth term. Let me highlight it here, the fourth term for this equation. Okay? Now it's giving me the value of the first term. It's giving me the value of the first term. And so that's going to be my springboard, is the first term. So I know that a sub 1 is 0. And I want to go about looking for the second term. And I want to use the equation that it gave me. Okay, so that's 3a to the n, so that's a to the second, because that's what my second term that I'm looking for, minus 1. And that is 3 to the power of a to the first. And I know the value of a to the first is 0, so that's 3 to the power of 0, that is 1. So that's my first term. And that's also the value of my second term, which I'm going to need in the next problem. So to find my third term, I use the same equation, a to the power of a to the third minus 1, which is a to the power of a to the sub 2, and that's 1, so that's 3 to the power of 1, which is 3. Okay, so now I have the value of my third term, which will aid me in finding the value of my fourth term. So that's 3 to the power of a to the 4 minus 1, which is 3 to the power of a to the a sub 3, which I know is a to the third, which equals 27. And that's it. That does it. That's the value of my fourth term, and that's what number 14 was asking me to do. Okay, so that's the sequence of steps for finding the term, a given term, the nth term of a problem. Okay, so I'm going to take quite a leap and go over to problem number 28. Problem number 28. These set of problems are asking us to find a partial sum for the term given. And in number 28, it asks us to find the partial sum for the fifth term. So I have here the definition of what we're looking for, and so let's go ahead and read it together. The nth partial sum, okay, of any series can be found by calculating up each term to the nth term. So in this case, our nth term for number 28 is the fifth term, and then finding the sum of those terms. So then I want to find I want to find the value of each term for the first term, the second term, the third term, fourth, and then fifth. And when I find the value of each of those terms, I want to then add them up together. So let's go ahead and start with the first term then. So a to the 1. So that means any time that whatever I have in this subscript, I replace it with the n in my formula. So since I have 1 there, that means I have 1 times 1 minus 4 times 1 minus 3. And then I just do the math at this point. So that's 1 times negative 3 times negative 2, right? Okay, so then that is essentially 6, and that's the value of A1. So I want to keep this stored away because I'm going to use that in a minute. So then now I'm looking for A sub 2. Okay, so that's 2 times 2 minus 4, 2 minus 3, and that is 2 times negative 2 times negative 1. So that's going to give me negative 4. Actually, positive 4. Sorry. Okay, so that's A sub 2. Now let's look for the third term, A to the third, or A sub 3. So that's 3 times 3 minus 4, 3 minus 3, and that's 0, so it's going to be, the whole thing is going to be 0, so A to sub 3 is 0. Okay, and now I'm going to do the fourth term, so that's, whoops, let me back up a little bit. So that's going to be 4 times 4 minus 4. Oh, right there, that's going to be 0. So automatically I know that A sub 4 is also 0. So I can stop right there. Now let's look for that final term. That's going to be 5 times 5 minus 4 times 5 minus 3. That's 5 times 1 times 2. And that's giving me a value of 10.
Is there any more extra markers here?
Okay, let's continue on. So, all right, I have the value for all of my terms up to the fifth term. Now, a partial sum, as you look at the definition, the partial sum can be calculated by calculating the term up to the nth term and then finding the sum of those terms. So I need to find the sum. So that's the first term. Actually, here, let me actually coordinate this by color. That's the first term, which is 6 plus 4 plus 0 plus 0, and then plus, I ran out of room, didn't I? No, I didn't. Plus 10. So then the value of all of these terms is 6, that's 10, that's 20. So that is the value, that's the partial sum, that the fifth partial sum of this sequence is 20. Okay? So again, the fifth partial sum for this one is 20. Alright, so let's try to work another one out so you can kind of see this at play again. So now I'm looking at 31. 31, I'm looking for the fourth partial sum. Fourth partial sum. So I'm being given the value of the first term, which is 64, and then my equation, negative 3/4 a sub n minus 1, and then my n must be greater than or equal to 2. Okay. All right. So let's go ahead and dive in here. So my second term, the value of my second term will be negative 3/4 a2 minus 1, and a2 minus 1, this here is going to be 1, right? So I'll go ahead and change it to 1. And I know the value of a sub 1. The value of a sub 1 is 64, so I can change this to 64. So times 64. And now I can just simplify. Okay, so as I simplify this is going to be 16 over 1. 16 times 3 is negative 48. So that's the value of my first term. So I'm going to highlight this. Coincides with a sub 2 there. Okay. And I'm actually going to highlight this one too because that's my A1. Okay, so moving on. So a sub 3, my third term. So that's negative 3 over 4 times a 3 minus 1. And so that's going to be a sub 2. So I know the value of a sub 2, and that's negative 48. And I can simplify this. 48 goes into 4 12 times, right? That's going to be negative 12, and then that'd be 1. So negative 3 times negative 12 is positive 36. And that's the value, and that is the value for my third term. Okay? And then my fourth term, which is my last term. This is the last one. So my fourth term is negative 3/4 times a 4 minus 1, which is negative 3/4 a sub 3, and another value of a sub 3 is 36. So that's negative 3/4 times 36. Simplify this to be 1. Oops, sorry, that's going to be 9, and that'll be 1. And then this will simplify to a to the fourth will be negative 27. And so recall that I'm being asked for the partial sum of up to the fourth term, so then I want to add these up. So that's going to be 64 plus negative 48 plus 36 minus 27. So then I just want to do that math here real quick. Okay, so the partial sum for this is going to be 25, and that's it. That's my goal. 25. That's the fourth partial sum for number 31. So I'm jumping over to number 35. And number 35 is asking me to find the fourth partial sum to this given equation. So as you remember, I need to find the value for each sum, the first term, second, third, and fourth term. So for the first term, and I'm not given the value of any other terms either, so I have to actually find the value for the first term. If you recall in the previous problems, I was given the value for the initial term, and then that helped me find the value for the next successive terms. So for the first one, a sub 1, I have the negative 3 raised to the power of, so I replace my n with the value of 1, and then divided by 10. So that's negative 3, that's negative 3/10, and that's that. That's the first term. So now I want to go and find the second term. So that's a sub 2. So that's negative 3, and then replace with the 2 to the power of 2. And that gives me 9 over 10. Okay? And that's the value of my second term. So then my third term is negative 3 to the third power divided by 10. And that is negative 27 over 10. Alright, I'm almost there. Fourth term. So a sub 4 is negative 3 to the fourth power over 10, and that gives me 81 over 10. So then now my next goal is to find the partial sum to all these. Now luckily, as I look at the denominator for each of these values, they all have the same denominator, so it's going to be a fairly simple add. So I have negative 3/10 plus positive 9/10 plus negative 27/10, and then finally 81 over 10. And I do my math there, I end up with denominator 10, of course, and then the sum of my numerators is 60. And this simplifies to 6. And that's it. That's my partial sum, the fourth partial sum of this sequence of numbers that I got is 6, and that is for 35. Now in the next set of problems I'm going to simplify this a bit by showing you a new symbol.